Good evening, children. Here we're going to go through distance and midpoint problems. Now, as I told you in class, there is another distance and midpoint video up on the YouTube channel. It's one of the first 2 or 3 I've done, so it's back at the beginning. It's also probably, I think, by far the most watched one I've done. And that's simply because distance and midpoint is something that repeatedly pops up. So, if you've watched that, still need a little bit of extra help, what I'm going to do here is I'm going to work through 3 or 4 problems, or apparently 9 by the number of pages, and we are going to go through them step by step and show you how to do them. So, as always, if I were you, first thing I'd do, write down the distance formula right there up top. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I would then go through the entire page and mark all of the sets of numbers as x1, y1, x2, y2. Again, I know this seems redundant. I'm sure you guys are sick of hearing this and doing this, but the fact is if you can sit there, mark them all as x1, y1, x2, y2, then when you're going through, you're going to have a much easier time of, a much easier time of just basically plugging them in and then algebraically solving the problem. So let's look at number 2, for instance. We already did number 1 in class. So the distance here, and we're going to put that square root sign down, that radical sign. And instead of x2, we're going to put 5. Instead of x1, we're going to put 7. Then we put that squared up there. Plus, instead of y2, we're going to put 7. And instead of y1, we're going to put negative 2. So that gives us 5 minus 7, or negative 2, squared, plus, and those two negatives are going to turn into 7 plus 2, squared. Negative 2 squared is 4, plus 7 plus 2, 9, squared. That's going to give us 4 plus 81. Square root of 85. Now, the square root of 85 is an imperfect square, so there's nothing doing there. Now, we also want to look to see whether or not we can factor anything out. The factors of 85 are 5 and 17. Both 5 and 17 are prime numbers, so there's nothing doing there. Okay, next one we're going to do is number 8. So we get those labeled x1, y1, x2, y2. Now I understand you don't have a ton of room on this page, so you very well may have to end up writing out the problems on another page and then either stapling your work shown page to the worksheet or just writing the answers down. I really would prefer you guys staple the work to the worksheet, because if I see a lot of people getting the same wrong answer, I want to be able to go and check their work and see exactly where things are falling apart. So that way, that can improve how I'm teaching it to you. So, what we're going to do, x2, negative 4, minus x1, negative 8. So we have negative 4 minus a negative 8 squared, plus y2, 6, minus y1, 8 squared. So we're just going to run the algebra through. Negative 4 plus 8 squared plus negative 2 squared. That's going to give us 4 squared plus 4, 16 plus 4, or the square root of 20. Now here, that's a fine answer. Okay, so you can be done with the square root of 20. I'm also posting tonight a short video on how to factor out radicals. And if you watch that, you'll see that square root of 20 reduces to 2 radical 5, or 2 square roots of 5. So the distance equals either one of those. Now, that's how the first 10 go. So the second 10, you're given a graph with a line segment on it and asked to find the distance or the length of the line segment. So here there's just an extra step, and that is identifying the points and then plugging them into the distance equation. So the distance equation you should still have it at the top of your page. So let's look at 11. That point, again, whenever we have an ordered pair, it is always xy. Horizontal, then vertical. So here, we're going to go negative 1, 5, negative 5, 2. We're going to go x1, y1, x2, y2. And then just plug it into our distance formula. x2, negative 1, minus a negative 5, that's our x1. We're going to square that, and then we're going to add to that y2, 5, minus y1, 2, squared. It's going to give us negative 1 plus 5 squared, plus 5 minus 2, or 3 squared. That's going to give us 4 squared plus 3 squared. And I just wrote 5 on the side, because this is a pattern that I want you guys to start recognizing. And this is a Pythagorean triplet, 3, 4, 5. So keep in mind that the distance formula is an application of the Pythagorean theorem. We went over that on day 1 of the distance formula, which means that we are basically treating that distance that we're trying to find as the legs of a right triangle. And yes, I know I just drew two blue lines. That does not mean we've done this before. So, if we have 4 squared plus 3 squared, that's going to give us 16 plus 9, or the square root of 25, which is, in fact, 5. So again, that ratio of 3, 4, 5 in a right triangle is something that pops up a lot. It's a really easy one for people who create problems to use and come up with. You'll see 3, 4, 5, or double it, 6, 8, 10, triple it, 9, 12, 15, so on and so forth. So if you can see that pattern, it really helps you know where you're going and that you're going in the right direction. So if you end up hitting, if you end up getting 3 and 4 as your two sides, as your two lengths, and then end up with an answer of like the square root of 97, you probably did something wrong. You want to go back and check your work. So one of the questions I get a ton is, how do I know which point is x1, y1, and which point is x2, y2? And the answer is, as long as you label them correctly, as long as you make sure that you're plugging them into the correct places pursuant to the distance formula, it does not matter. Remember, distance is always positive. That the distance from here to Sedona is the same exact as the distance from Sedona back to here. So it doesn't matter whether you're figuring out the distance from negative 1, 5 to negative 5, 2, or whether you're figuring out the distance from negative 5, 2 to negative 1, 5. And here, I'll quick show you the opposite. So if I switch those around, so if I make negative 5, 2, x2, y2, and negative 1, 5, my x1, y1, watch what happens. Now my x2 is negative 5, minus my x1, a negative 1, squared, plus my new y2 is a 2, minus my new y1, which is a 5, squared. So I'm going to get negative 5 plus 1 squared, plus negative 3 squared. That's going to give me negative 4 squared plus 9, which is negative 3 squared, or 16 plus 9, which equals the square root of 25, which equals 5, which is we got the other way. Again, distance is always positive. Distance determines the length between two things. Doesn't matter which way you're measuring it. Top to bottom, bottom to top, you are all the same height. Okay? It doesn't mean that I'm 6'1", so it doesn't mean that I'm 6'1" unless you count from my head to my feet, and then I'm negative 6 feet 1 inch. Okay? Distance, length, measurements are always positive. We can't have a negative distance. Okay, so it doesn't matter which one you pick as x1, y1, which one you pick as x2, y2. Just pick it, stick it, and go through the equation. So let's look at number 12. We got 2 points here, 5, 0, and negative 4, negative 2. In general, I tend to go left to right in labeling x1, y1, x2, y2. So then when we plug it into our distance formula, we go x2, 5, minus x1, negative 4. So we have 5 minus a negative 4, squared, plus y2, 0, minus negative 2 squared. So that's going to give me 5 plus 4 squared plus 2 squared, because I have 0 plus 2. I figure you guys can do that in your heads. So then we've got 9 squared plus 2 squared, or 81 plus 4, the square root of 85. And that's how you want to go through numbers 11 through 20. If you're having additional difficulty with that, go back, rewatch this. If you're still having trouble with it, just ask me tomorrow in class. So, moving on. Here we have midpoints. So 21 through 25, you're asked to find the midpoint of the line with a given endpoint. And that means that you're going to use these formulas, the x1 plus x2 over 2, and then y1 plus y2 over 2. And you use these formulas when you are given the endpoints and asked to find the midpoints. Okay? So when you have two endpoints, you're asked to find the midpoint. These are the formulas you're going to get. So when you label them, you're going to label them x1, y1, x2, y2. And then you just plug them in. So they have negative 3 minus 10, negative 13 over 2. And 4 plus 3 over 2, or 7 over 2. Now if you want to leave that as an improper fraction, absolutely okay. You can also bust it down to a decimal, negative 6.5, 3.5. Either one of those is fine. Really doesn't matter to me whatsoever. So, when you're doing, again, when you're doing these no ones, 21 through 25, where you're being asked to find two endpoints, where you have the two endpoints rather, and are asking for the midpoint, this is the equation that you do. So what that would look like graphically, here's your little graph. You're given a mid endpoint here, an endpoint there, and you're being asked to find the midpoint. Okay? So we'll do another one of those. Let's look at 24. We have 6, negative 6, 10, and negative 2, 2. So I'm going to go just left to right, x1, y1, x2, y2. And then plug it into my equation. Remember, my equation is x1 plus x2 over 2. That gives me the x value of my midpoint. And then y1 plus y2 over 2. That gives me the y value of my midpoint. When we first did midpoint, we only did a plus b over 2 because we were only dealing in one dimension. Okay, we were dealing on a number line. So we only had one coordinate to worry about. Here we have an ordered pair. Pair means 2. So we need to run all these calculations twice. Once for x and once for y. So we get negative 6 minus 2, or negative 8 over 2. 10 plus a negative 2, or 10 minus 2, that's going to give us 8. So that gives us a midpoint of negative 4, 4. Hopefully that makes sense. If not, feel free to come in at lunch. If you're just not getting this, if it's not making sense to you, come in at lunch, we'll work through it. I'll figure out kind of maybe a different way to explain it. And there goes my bird. Haji, what you doing? And he's back on his cage. All is good in Renard land. Okay, moving on. So, now we have these last set of problems, and this is 26 through 30. Go to bed. Not you guys. You guys finish watching this video and then go to bed. The bird needs to go to bed. Okay. So here we're given the endpoint and the midpoint and asked to find the other endpoint. Okay. So what I'm going to do is I'm going to work through these and then I'll show you kind of graphically what that means. So think about it this way. If I am given one endpoint, let's say on the number line 10, and then I'm given a midpoint 20, and asked to find the other endpoint. So if I say I'm going to start at 10 and move to 20, and that's halfway there, what's at the other end? Well, the answer would be 30. If I start at 0 and go to 50, and I'm halfway there, what's at the other end? 100. And that's all we're doing here. We're given a starting point, the halfway point, and we need to find the finish line. So how we do this is we need to find that other endpoint. And remember, from before when we had those endpoints, they were x1, y1, x2, y2. So what we're going to do is we're going to label the endpoint we've got as x1, y1, and we're going to label the endpoint we're looking for as x2, y2. We're then going to introduce x sub m and y sub m, and that's going to be the x value of my midpoint and the y value of my midpoint. And we went over in class how we got these. We got x2 equals 2xm minus x sub 1, and y sub 2 equals 2 times y sub m minus y sub 1. So we're going to label our points. We're going to do number 28, x1, y1, xm, ym. Remember, x1, y1, that's our endpoint. xm, ym, that is our endpoint. So now we have that, and we're just going to plug them into those two equations that we got. So we're going to go x2 equals 2 times xm, that's 2, minus x1, that's negative 10. So that gives us x2 equals 4 plus 10, or x sub 2 equals 14. We're going to do the same thing for y, because again, we're looking for an ordered pair here, so we need to do these calculations twice. So we're going to go y2 equals 2 times y sub m, that's 9. Again, y sub m simply means the y value of our midpoint, minus y sub 1, that is the y value of our endpoint. So we get 18 minus 1, or 17. So that means that we have now the ordered pair of 14, 17. So what I want to do now is take a look at this graphically, okay, to show you what we're looking at. Is that the dog? My dog's snoring. Anyway. So that's the work we just did to get 14, 17, and I'm going to color code this. So I'm going to have my x1, y1 is yellow, my xm, so that's my first endpoint. That's my given endpoint. I'm then going to have my xm, ym, that's my midpoint, as purple. I'm going to have my x2, y2, that's my other endpoint, as blue. So let's graph these out. First point I get is right there, yellow, negative 10, 1. I am then told that that's an endpoint. So that's my starting point. My halfway point is now at that purple mark, right? And that is 2, 9. So that's the information we're given. So what we know is that we start on that yellow dot, we race towards that purple dot, hey Cleo, and we are looking for our blue dot, the finish line. Haji, go to sleep. He's not going to go to sleep, so I'm going to take a quick break and go tuck him in, and I will be right back. So, as I was saying, we have our starting point, negative 10, 1. We have our halfway point, 2, 9, and we're simply looking for the other endpoint. So, we know if we just kind of eyeball it, that the other endpoint should be there. If this right here is our starting point, this right here is our halfway point, then our other endpoint should be somewhere around here. Now we have 14, 17 here, and look where that gets placed, right there, 14, 17, smack dab in that kind of circle of expected answers. Because when we circle that, we're like, you know what? Our answer could be anywhere in this area. It has to be on the line, but I'm just eyeballing it here. So when our our dot ends up in that area, it should give us a certain level of confidence that we're getting the right answer. There's another way to check this, and that is we can sit there and go use basically slope. Rise over run. We can go from -10 to 1. We're going to go up a certain amount and over a certain amount. Now, if this is a straight line and 2, 9 is the halfway point, we should then be able to go over, up and over that same amount to get to our second point. And that is 8, 12, 8, 12. And that makes sense. So if we had gotten different numbers there, probably want to start over, go back, check our work. Hope this made sense. I'll see you guys tomorrow.